Okay. No. So hello everybody. Thank you for having me here, giving me the chance to talk about one of my favorite topics over the last weeks and months. Okay, cool. It's SBOMs. My name is Jan Thielcher. I am here from the company called IIoTSBOM, and the product is called TrustSource. And I want to give you first a very quick introduction to who is talking to you. Then I want to elaborate a little bit on the producing the SBOM, so on the practical parts. Okay, given you have an SBOM, how to handle the SBOM, and what you can do in automation to get this resolved, because it's in the end, it's nice to have, it's important to have, but still it does not gain any value in the first place. So it's a good idea would be then to automate the stuff. So let's start. Before we start, actually one more question. Whom of you is actually producing software today or software building materials already? 1, 2, 3, okay. That's interesting to see. Whom of you is part of a PCERT, a product security? No?
Yeah, actually, yes, but
more
trying to coordinate one. Yeah, okay. Coordinating one.
Okay. For those who do not know, PCERT is a product security response team. So in case you have some products in the market and they are under attack or at risk, then the PCERTs are actually taking care of this. So given you have, for example, machinery that is remote accessible or exposed to the internet, it would be good to have such a team that's at least capable of knowing what it should do in case there is something that it needs to take care of. Okay, so who's talking? IIoTSBOM, that's my company. It's founded over 20 years ago. We're actually architects. EA stands for enterprise architecture. So it's the time of 2000, 2002 when it came into life. We're supporting customers in making business digital. So we started inventing all these sort of IoT things a couple of years ago. We've helped Class, for example, to build 365 FarmNet, which is a software as a service solution that helps farmers to do all their jobs and having financial accounting done immediately in the background by doing some transactions and so on. So it's getting new business up and running. And we do this actually very much under the use of open source. And then we recognized that we ran into some compliance or legal issues when we were handing over our solutions to our customers. And we started to think about SBOMs, because we needed to understand what is actually inside the solution that we are providing, to hand it over to our customer and to really have a legal handover made possible, because we are not allowed to actually sell the stuff that we have produced, because we were using open source. It comes with licenses, and these licenses do not necessarily allow us to just throw it over the door. So we had to exclude the stuff that we used from the stuff that we sold. And since we are just senior architects, and we pull together the teams, so we have hundreds of developers, and they do everything from whatever they are used. So we have no clue how they are working with this. So we needed to automate the analysis of what is actually composing the solution that we are selling. And this is where we started to enter the SCA area. And the result that you see is this TrustSource. I mean, we came up with an own software as a solution service that is automating the complete SCA plus whole management thing that you need to get all this compliance stuff ready. And because when we talk about SBOMs, SBOMs are supporting many use cases, not only the compliance use case. They also support the security use case, that's why we are here. And they also support technical management use cases, where I will take you on later on, so as an additional benefit. And that's why I think that SBOMs are so important. But before we go into this detail, I will give you a short understanding of the cool solution, because this is, I mean, we really ran into this by heart, because we really improve ourselves all the time. We understood first that we need to do the software composition thing. And we understood we are handling many technologies, so we'll talk about this later. And we are challenged with the analysis part on very different levels. We had to find ways to export the information that we are using, and also to import, because some parts are already covering the things. We identified that assigning vulnerabilities can be a challenge. I will be talking about this a little bit later, but we have solved this mainly. And that also, as you just mentioned, it's good to know there is a vulnerability somewhere, but what if nobody notices it, or how to take action? So what is the next stuff that comes? Then we understood we're not only using components, it's not only about software as that we use as code, or where we are coding, it's also that we are using software as infrastructure, whether it's in the operating system level or databases, middleware, whatever. And then we understood when you want to roll out the whole stuff into an organization, there are hundreds of people that do software development activities, but none of them has the hat to say, I have to take care for creating the SBOM, or for handling this, or for making sure that the vulnerabilities are there. So there's a role model required to make actually activities that are associated with these tasks happening in your company. Because just pushing out the SBOM is nice, and it's a prerequisite, but it does not help. So policies to enforce things, all this is part of the cake, and all this can be handled in TrustSource. So why would we actually start producing SBOMs? Transparency is the main case. Transparency for compliance. As I just said, I need to understand what is in my solution to be able to understand what licenses are associated with whatever I'm using in this solution, and what are my obligations to legally be allowed to use this software. All this open source software is nice, but even an Apache licensed software requires you to make a notice to your customer, A, of the license, and B, if you're going to change it, to make to announce your changes. If you don't do this, you are not allowed to use this Apache software in your product. There are other products or licenses that do not allow you to sell this stuff. So you must exclude them and ask your customer to put something aside, or inform him that this is delivered but not part of your product. There are some things here on this compliance side. The second thing is security. We have already talked about, you won't understand that there is something in your product if you do not know what your product consists of. It's not said that when you know what your product consists of, that you know all the vulnerabilities automatically, but you have a better chance to meet them. And that's a prerequisite to really make your product safe. And also, it's a prerequisite to understand what you need or should communicate to your customers. There's another topic, export controls. Typically, when you start selling software outside your own country, it might happen that governments are interested in what kind of encryption your system can use. I was recently talking to the software AG, and I learned that even when you sell to France, you have to tell the government, the French government, what kind of encryption capabilities you have inside your product. It's not whether you're using them or not, but it's about the capabilities, and you have to list them. It's interesting, I didn't know that. We're not just talking Saudi Arabia or other areas, it's inside Europe. So export controls might also profit from having this understanding. And finally, for sure, maintenance. I mean, there are components out there, they are aging and nobody cares for them because they're just somewhere in the product, they're somewhere down there, and nobody really takes care. And all of a sudden, it's too old. And you have then version jumps. Or a very important thing that happened in the last 2 years, comes up more often, especially as a start of a supply chain attack, is dependency confusion. It's something that is used by attackers. They see and search from or understand from GitHub repositories or other analysis what kind of software is used in particular products. They provide a library with a very high version number and put in their malicious code in there, and it automatically will be pulled if you have your dependency management not on a strict release or version indicator, but have just say, take me the last. And this happened to Apple, for example. So it's nothing that is totally out of the world. Yeah. So version control is an important part of your security and also of your maintenance. And then there's another reason for doing this. It's about technology management. Technology management is your own technology management. If you have only one product and you have only, let's say, sort of a device software that is giving you some operating system and a little bit visualization to make a machine talking to its users, then probably it's not that much of an importance in the technology management. But if you're a software company and you're running 100 products, then it absolutely makes sense to understand the stacks and to start to funnelize this towards a more homogenized architecture. And here, using SBOMs is a cool tool, because I mean, it's not just something that you produce for the sake of producing it or for informing your customers, it's also for your benefit, because you now understand what you have in your products, and all of a sudden you can start doing what actually machinery people are doing for years. They sort for common parts and they start putting things together to be more productive, to be more efficient, and probably even to purchase better. This is all can be done with this technology management, which is then what we call portfolio harmonization. So you can understand what I have and make probably boxes out of it, or even isolate sub-services. This all said, I think we are at a stage in the evolution of software development where we can say software bill of materials are relevant. And they should be part of a good, as one of my customers has put it, actually it's not a choice to do software bill of materials, it's actually good manufacturing practice. You would not expect any machinery provider not having a bill of materials for his machinery. And so why should we as a software producer? So, but okay, when we talk software bill of materials, sorry, this is in German, so hope you can understand it. It's actually what we see on every product. It gives you information about the ingredients. What is used inside this? For some parts, this is pretty clear. Okay, there's probably hazelnut in there, yeah. Hazelnut, I have a good understanding. I don't know which tree, but at least hazelnut, yeah, have an understanding. But what is E220? Does anyone know? Or emulsifier? Does it tell you something? You can find this on these things. I can't live with that. But just assume that you're providing or receiving an SBOM, and then you find there's Spotlight. Okay, what's Spotlight? Spotlight? What's that? It's a JavaScript library, actually. It's widely used, but if you don't have any version number, if you don't have a clear link to where it comes from, it's pretty useless. So it can give you an indication, but it's very bad. So the good idea would be that when you create SBOMs, they should be, on the one hand side, it should be an information that someone can work with. So from my point of view, or from our point of view, there's a URL, a PURL standard or specification appeared. I don't know really when, it was a couple of years ago. And this is a nice way to describe a component. It gives you a structure, the ecosystem, the package, the organization, the version, all this is included. And it helps. This is really cool thing. And even the National Vulnerability Database in the next format, which will be version 5, I think, will use this to describe, because they understood that the CPE format, which is the Common Platform Enumeration, which is used today, has its problems. To say, I don't know, who's familiar with CPE? Okay. So did you already do some trying to find open source components and assign them based on CPEs?
Yeah.
Yeah. What were your experience?
It's a bit challenging.
Yeah. So the problem is that the CPE has been designed in a world where we talked about Microsoft Internet Explorer and so on. So it's a clear organization and it has a product. And so this is the structure that CPE follows. And it's not what really is required. When you talk open source components, there's a project. It doesn't have a real organization. Maybe the project is, then it's called, the project has the name of the it's the same organization name. So on, you have difficulties. Then it's, there are projects out there that are called cloud something. And then you have 100 other projects that have almost a similar name. So how do you do the matching? What is where do you associate? It really is a trouble. And we were only able to resolve this by introducing different confidence levels. You may be more or less confident in assigning these things, and then allowing customers to filter on this. But however, it also is important to have everything included. Because if this list does not contain the weed, the celiac patient will still suffer because he is missing the weed. And if he eats weed, his celiac illness will increase. So we need to be complete, and being complete for software bill of materials is really hard. Just imagine you see a machine that is ready and you want to have the list, and make sure just from watching at the machine that you have all little nipples that are somewhere built in there on your list. And the same we have with software. The same problem to be complete on a software solution that you're providing. That's what, as you said, what is the scope of software, of the software bill of material? From my point of view, whenever you start with a little bit that you're developing, try to make a software bill of materials for this, and whomever is consuming it can evolve and put his stuff, what he's adding on top of it. And this will then make sense because it becomes more and more and more, and the software bill of material will grow and grow and grow forever what kind of solution has been provided. And then there's another thing. We are producing software and we are testing software. And the question is, does the test stuff belong to the software? We always advise our customers not to include it because it's not of relevance, as we just discussed. I don't care if the testing tool has a problem. It's a problem of the manufacturer who is selling me the software. It's not my problem as a customer who's using it. So leave off the dev dependencies. Yes, it's important if you want to tell someone how to produce or reproduce my software, but it's not important for me as the customer. So finally said, SBOM should include all that is inside the software that I'm going to consume. There are standards to describe this. You do not need to start from scratch. There are two, more or less. The first is SPDX, that's most likely the ancient dinosaur, you say. They are around for a couple of years, over 10 years already. The software package data exchange has its origin in the compliance part. It comes from the legal perspective. And if you look at this package information, file information, snippet information, other licensing information, relationships between SPDX elements and annotations, if you see this, it's fully assigned for compliance. Yeah, you can use this for legal compliance. And it's not really driven to cope with this complete SBOM topic as it's seen today under security perspective. I mean, it has all the capabilities, and the recently released version 2.3 get a bit more flexible, and even 3.0 already under construction is coming with more information and allowing to describe more. Why? Because Linux Foundation has seen what OWASP is doing. OWASP was doing the Cyclone DX, and Cyclone DX is coming with much more wider approach, and it has this extensions part. And these extensions allow Cyclone DX to really define things and add them as extension into this definition. So this is also something that you can use to handle internal information for yourself. So within your organization, I mean, when you create SBOMs, use them, make them not just being a kind of a workload that you have to carry, make them something that is livable, that is active in your organization, and then they will be correct. Because this is also important. Yeah? I mean, having good information is one thing, having the correct information is another thing. But as you see, the Cyclone DX has metadata as well, component services. It allows even to integrate endpoints from services that your software is consuming. It describes the dependencies and allows to introduce information about vulnerabilities. They have the specification links I have put in here, so you can use the slides for reference. We will send out the slides later on. So then all the links are always in here. And we have been talking recently about getting the information. Yeah? And they have been even defining the so-called SBOM exchange API. So there's this OWASP dependency track. It's a little container that you can start, and you can start doing collecting the scan information, your SCAs, and this will then be possible to create SBOMs and distribute them. But I was talking about getting them complete. We have totally different tech stacks. We have, for example, we have C and Go. There is no package management, not really. I mean, Conan was was a way to start package management for C. But you have here you need to do a file-based analysis. The repository is the scope of what you're looking at. And then you have the problem of sub-repositories and other things that are torn into the stuff, or even libraries that come from somewhere else. So you have to really make sure that what you're scanning is what you really want to put out. That can be complex, and having the right scope here is absolutely essential. There are many free tools out there, but you must be sure or make clear that it's a different thing than to work with any of these environments where you have package managers. Package managers pull packages based on the definition what comes into the product. So they have predefined packages from somewhere. And here becomes the next topic. Yeah? From where? Where does this come from? Is this hosted in Maven in the public repository? Is it hosted in my local Maven? Is it hosted in probably some third party, wherever, where I don't have an understanding that what comes as under this package number is exactly what I'm expecting? Within the software supply chain, whenever you use package management, you have to make sure that the packages that are used are the one that you expect. That's the very first thing, because then otherwise, if you get a Maven component XYZ 1.3, and this is not exactly identical with the one that you have expected, you have no clue of what's in there. So whenever you build software, whenever you produce software, make sure that you have an understanding of the package, where does the package come from. And it's getting even worse.
It also includes the build tools, I guess, like the compilers and things like that, because they can introduce vulnerabilities as well.
Sure, that's right. Yeah.
You say it's a challenge, but I say it's an impossible challenge because it just goes in so many directions.
That's right. There's especially when you say the compilers can introduce vulnerabilities. Yeah, that's important. But in the sense of a software bill of material, it would be actually the origin of where you ever build it. Yeah, so then this would be a weakness or vulnerability of the particular component that you are, or library or whatever you are producing in this field. Yeah? Because it would be introduced at this particular step, and then it would be something that is specific to your whatever result. Yeah? When you pull a package that has malicious code, vulnerabilities, whatever, it has been built somewhere. It's introduced into your product, even if you would have made this most serious and best software that hasn't any issues, you still get a vulnerability introduced there, in case you're using that code. So that's why it makes a little bit of a difference. But you're right. That's also something that is important. It's not only some vulnerabilities only affect specific architectures when we talk about computers, chips, and so on.
Well, another issue that I see is software that's embedded into hardware components.
Might be relevant.
Like NFC that is in every smartphone. I happen to work with this in the hardware. It's a chip which has inside the chip a microcontroller that runs a proprietary software that we don't know. It's closed source, but it could have a vulnerability which may be hackable or whatever.
Absolutely.
So
that's absolutely right, and that's why actually everybody who is consuming things that that is run by software should ask for the software bill of materials for his supplier. So then, if you ask for their software bill of materials, and that's why we have this SPDX import, for example, or CycloneDX import, you add it as element to your solution, and you have the full stack. Given the software bill of material would have been complete. I mean, but this is then in the responsibility of the supplier And you can make your legal work in a way that you say you're confirming that the software bill of material that you're delivering with this chip will be complete. And then legally, at least you're on the safe side. But as Ashwin is assessing, probably you are one of the tiers that's somewhere in between. But this makes it even more relevant to really make sure that you are aware of this topic, that you take care by yourself, and that you then get this material from your suppliers as well. Using containers, lovely Docker, I love it. It's so cool, it's so fun, it's so fast. But when we talk about software distribution or solution distribution, never ever start deploying Docker files to anyone that you have not built. And I mean from the scratch. It's so simple to pull the cool environment, but you have no clue what's in there. I mean, there are solutions. You can scan Docker files, but still, I mean, there's a little copy. I take a security image, I make a couple of actions, I install a couple of components, all can be found, and then I have a copy file, a little copy directive in my Docker file, and it just copies in a shell script. And this shell script is then doing whatever it likes because it has the correct rights in this level. To find this is even a challenge for those scanning tools. So better take care that you know what kind of Docker files or what is inside your Docker file that you're executing. And I mean, even here, binaries, it's a chapter for itself. You have all the specifics. You have your when you want to assess binaries, you need to know which is the architecture, what kind of compilers have been used, as you just mentioned. It's really something that here we are not capable. Our solution is not capable to do anything in that area. This is what we do as a service in the consulting part, because it's so specific. We cannot support this. But having understood that pulling together the solution from different sources requires different analysis, I think it's absolutely essential that you make sure that you have something you can associate to things in the outside world. So whatever these things produce, they should have sort of an indicator, and as I've already said, PURL is my favorite because I think it has a great future. But again, we're not done yet. There is more about it. It's cool to know about my own code, but my solution will probably contain middleware. It will contain other architecture elements. It will contain libraries. And this should be part of my solution as well. And I should, and this is, well, as you just asked, the scope of a software bill of material should not be only a little library. It should be what I am selling to the customer. As long as this, what I'm selling, builds a closed ecosystem, it can be vulnerable from any edge. And this is what if I come from the security point of view, important to address. Okay, now we have an SBOM. We have described it with any of the standards. We have made clear what's in there. We know that we have it complete because we have also the infrastructure addressed. What are we doing with it? Is it valid? Who tells me that it's valid? If we are in a supply chain environment and someone hands me over a list, hey, this is what we did. Can I believe it? How long does it last, this information? We are talking about software updates over the air. Where does the next SBOM come from? Does it come with the update over the air? Is it sent by email? Does the one with the sent by email comply with the one that I have in my solution rolled out. Not really simple. And to address this, the OpenSSF, it's a working group of the Linux Foundation, has taken care and developed something that is called SIGSTOR. It's a solution that addresses actually this problem. The idea is the developer is actually having when he's building the artifact, and he's aware that he's in a very certain stage of having this artifact reliably. Then he requests a certificate. He will be provided with a certificate, does a signature, and signs the artifact. And the signature or the signing certificate with this information about what it has signed is put into a immutable ledger. And then whoever is actually retrieving such an artifact can check the signature against the ledger to verify that the SBOM that he has got has to do with the binary. I mean, it does not guarantee that you're really getting the complete list of things.
Is it also signing the SBOM too? Like you're signing the code in
No, it's just signing the artifact.
Still spook the SBOM.
Yeah, that's right. That's right. The SBOM is still spoofable, but given you have the SBOM that is probably addressing the artifact, then you would actually have an idea of what's in there. I mean, given the guy before has done the right job. There's a family of tools that has been developed for this. And I mean, if you are, for example, a company that is producing software, and or you're a producer of software in the sense of we are producing software to distribute it somewhere. It might be a good idea to have some sort of SIGSTOR as a private solution to ensure at least the reliability of the stuff inside your organization. Yeah. So it's all open source, it's all free. It's a little bit of hassle to set it up, but you can set it up for yourself internally, and it will help you on that way. Yeah. We are currently compiling this setup so that we can have this probably as a kind of a pre-set up to allow it, but it's still under construction. This is a recent development. I think SIGSTOR has been announced this summer. I think it has a future, as usual. I mean, it's American, and it's currently operated centrally by all the conglomerate of the tech giants. I don't know whether Linux Foundation or one of the tech giants has its hands on. But today you could go download the library cosign for containers or the Skit sign for your own software, and then start receiving a certificate from Fulcio, which is the certificate authority. It's something like they did for this SSL stuff to get this, the certificates for web security. How's it called? Let's Encrypt, exactly. And this is the same idea behind it, so that everybody, it's so simple and it can be used for free, so that everybody is going to use it. That was the idea behind it. The next thing we've been talking about is making the vulnerability or extending the SBOM by using it as to assign vulnerabilities. That's the most logical part if we talk about cybersecurity. And so here we run into this topic what we just addressed, matching known vulnerabilities to the ingredients of your bill of materials. This is a challenge. It's not, and also first of all, it's content-wise, it's a challenge because you need to put the things together in alias-wise. So and then also it's a matter of personal power. I mean, we're talking about a couple of hundred changes per day. I mean, this does not. So if you have a good SBOM, and you have not taken everything into your product, then you can have probably 1 or 2 that you look at per day, or less depending on whatever you're using. But it is something that requires attention, and so it's best to really push it directly to those who understand what they are looking at. That's what we did, because I mean, it does not make sense to have someone in a central department sitting there and looking at the alerts that pop up for there's a vulnerability in your dependency XYZ. Nobody will handle this. The only thing that he can do is pick the phone and call the developer, and he doesn't know who's the developer. So best is to have actually, when you know where the SBOM is created, when we are reading while the commit is done, what is assembled, and we push the SBOM there, and we know who's actually done this, that we directly alert these people about these sort of information, because they know when it's time and whether it makes sense to take care or not. The next step then should be that this guy is really reviewing it. It's cool that you inform the people and give them an alert. Hey, look, here, there's something wrong. But this does not really ensure that someone is really doing something. Yeah, I mean, developer has to deliver, and he's not there for just for his sake. So how does it come that the team who's responsible for this particular product is really having an issue that they have to take care of? When you automatically push the stuff into their workload, this is an absolute prerequisite to get it resolved. If this doesn't happen, it's not a ticket, it's not there. An email is forgotten. Yeah, so make sure that the alerts appear in the backlogs. And then when they decide what to do, it's about to create the corresponding VEX document. Here we are, we've been talking about VEX already. VEX is an extension to the CSAF standard 2.0. It's made for product responsible teams. And it's a recommendation on how to handle or to inform about what is with this vulnerability. So first of all, it's raising the hand, hey, we have product vulnerability here. And then you can give a status, and status saying it's under investigation. We are about to resolve this. We have this resolved. We are not impacted. Yeah, that's what we can tell. And this is a machine readable format. And this allows then people who are consuming your product to stay calm in case you are, yeah, they know you are aware of it and you take care of it. Yeah, and this is helping them a lot, because finally you will probably then say, we have solved it, or we are not impacted. Yeah, and if you have solved it, then probably there's a bump into it. Make an upgrade, do this, do that, which is typically the solution. So if you want to know more about this, you can find the whole specification under CSAF, GitHub Oasis TCS CSAF. That's the complete specification. And then you find also in the Cyclone DX, they have taken this, have put the VEX discussion on the table to make it more familiar and put themselves a little bit forward in this communication. Here we can also the standard has been given a couple of use cases. That's a very useful information, I think, especially from the vendor perspective. They have said, okay, what is if you have one product and one vulnerability, if you have one product, many vulnerabilities, and so on. They have produced such a list of use cases. And they are public here, and they have given VEX documents or VEX specifications for these particular use cases, how they should look like. So they really get an understanding of what is expected in the format. And there are slight differences when you look into the CSAF and into the VEX use case things. But the good thing is these two links show you the corresponding use cases, because they both took the use cases and put in the implementation for their standard. So this will help to make a complex story a little bit more complex. We have different versions. We are always running. I mean, sometimes, as probably the closer you are to hardware, probably the more you will face this problem. Your installed base in the market will typically have different versions and different version histories. And when you're assessing vulnerabilities in your product, you should help these people to find their way through. It should not only know, oh, we upgrade to version 3, it's all done. This might not be an answer for someone who's sitting here. So I'm sometimes I'm asked, who the hell shall do all this? And in the end, it's those that are producing the software. It's your job, but probably there's the option to let your customers pay a premium for being updated in time, in detail. I think it's possible for some products. It's not necessarily possible for everybody, but it might be an option to gain some more revenue. Okay, but I want to have one more point, which is, given I have a structure, I have an SBOM of my project. Yeah, it's my app. This app has some infrastructure. It's using a Wildfly as an application server. It's using MySQL as the database. It has my core code. It's my own development. It's everything that I own. And then it has a front-end module. There's Qt used. Probably some of you will be aware of. In the version 5.10.1, and there's some other JavaScript edits, some libraries for visualization, charting, and so on. And also, I use the connection module from another project inside my house. It's kind of inner source thing, and I use this in the version 2.13. So all semantic versioning, all cool. I love semantic versioning. I clearly understand what's inside my product or my app. And this is my cool app. What can I do with this?
Oh, great, because there's much more that you have not on the list there. What's your operating system? What's your file system that's below it, etc. It's all software.
Yeah, maybe that depends on the scope of what I'm selling. If I'm just selling, for example, all this and leave the operating system to my customer, say I'm running on Docker and that, so probably I should cover that. But you're right. Yeah, in the end, what is the execution environment? Yeah? But given I have such a list, what can I do with this data that I'm not doing today? What can I gain from it? And I think we can use it as input for threat modeling. Why am I saying all this? I mean, we are selling this sort of automation for this complete procedure for a while, and we see that it's not in the scope of developers to take care of this. Yeah, they want to develop. They do not want to do this administration of parts. So we were thinking about what can we do to make use from this data that is also useful for the developers, or at least for their management, so that they have to take care of it. Threat modeling is a great thing, because when I have this list, I know the nodes that I have to put in my threat models. I can start taking this as an initial case so that someone just has to make the arrows, and it will help me to get the people motivated to start doing things. If, for example, a complete threat model would be part of what I have to deliver as a definition of done, I can make use of this input. And it will be more complete because I already have this infrastructure in there, which is typically not in the scope of the developer. And what also would be cool, because given I have this SBOM and I can do the vulnerability assignments, because I have now the SBOM, I can make the matches. I then can show the weaknesses appearing in the model. So here, this gives me a live picture of my current risk. And this makes it much more active. Here it starts developing benefits. So the SBOM is not just a workload, it's benefit. This, yeah, so we'll continue later here. So then how do I get this off?
Okay, yeah, that's maybe a good idea. Yeah. So, Gonna, can you hear us?
Yes, I can. Can you hear me?